Hi everybody, this is Wemmje, and welcome to my Love VFX course, in which I will talk about the creation of my fantasy short film nöck with Nuke Studio. You can find the link to my short film in the description of this video. In this lesson I will focus on the creation of shot 150. Shot 150 is by far my favorite shot of this project. Months before shooting the short film, I even did a test with this shot, to see how far I could push the look and quality of the creature, and I'm very satisfied with the result. This is another shot in which we are seeing the point of view of the young girl. It was very important to me that the creature would look believable, and there are many things I had to do to achieve this output. I believe it was the combination of the sculpted model, the high-resolution textures from Texturing XYZ, the animation, the V-Ray skin shader, the hair, the lighting, and of course the compositing, that really helped to sell the realism of this creature. Alright, so let's take a look at the script. In the footage backdrop at the top, we have the deep rendering of the creature, the STMap setup that I have talked about in lesson 5 of this course, the plate, the denoise plate, the noise plate that I have used to reduce the fixed noise pattern, which I have also covered in lesson 5, the grain plate which I have talked about in lesson 6, a pre-rendering of the creature's shadow, the 3D camera for the shot, and an old render test of the creature. Now, the only reason why I kept this old rendering of the creature is because I wanted to highlight a problem that I ran into during the rendering process of the creature, and a solution that I came up with to solve this problem. If we take a look at the alpha channel of this old rendering, and focus on the left side of the frame, where the shadow of the creature should be, you can clearly see that there's a rendering problem in this region. For some weird reason, V-Ray didn't want to render the shadow of the creature on the photogrammetry scene geo correctly. Maybe the geometry was not clean enough. I don't know that for sure, and I didn't have a lot of time to figure that out. I just needed to fix it as soon as possible. That is why I decided to create the shadow setup in Nuke, but I will get to that in a moment. Just like in all of my comps, you can see the usage of stamps in this comp, which you can think of as a postage stamp system on steroids. If you want to know more about stamps, you can check out lesson 6 of this course. Right after denoising the plate, I color corrected it with an OCIO CDL transform to make it a bit brighter, and I used the masked color correct node to reduce the highlights on the leaves. In the OCIO CDL transform, I changed the value of the slope knob from the default value, which is 1, to 2.6. The slope knob of this node is the same as a multiply. After color correcting the plate, I defocused it, and then I added the shadow of the creature to it with a color correct node and a mask of the creature's shadow. I have already explained why I had to create this setup, and now I'm going to walk you through it. At the top you can see a rebuild of this shot's 3D scene, which consists of the scene geo, the textured geo of the animated creature, and a directional light. Both of these geos are Alembic files from Maya. To make this setup work the right way, I have matched the position of this light to the position of the light in the original 3D scene in Maya, and in the Directional Lights Shadow tab, I checked the Cast Shadow checkbox. To hide the creature in this rendering, I connected a constant and a multiply node to the creature's animated geo. The constant's channels knob is set to RGBA, and the color knob is set to 1. The multiply node's channels knob is set to RGBA, and its value knob is set to 0, which disables the primary visibility of the creature for the ray render. Using a scanline render would not have worked, as you can see here. After the ray render, I applied the lens distortion to this output with the STMap node setup that I talked about in lesson 5. Adding the lens distortion to this output is necessary, because the camera for this shot is based on an undistorted version of the plate. The ray render does not have an overscan option, which is necessary in this case because adding the lens distortion to this output without having an overscan would leave us with pixels that are being repeated at the edges of the frame. To solve this issue and to get the overscan I needed, I connected a constant and an adjust B-box node to the background input of the ray render. The constant's channels knob is set to RGBA, and the color knob is set to 0, and I set the adjust B-box node or adjust bounding box node to add 100 pixels, which gave me enough overscan with the ray render to cover the frame after the lens distortion. After the STMap node, I created a pre-render, which I placed in the footage backdrop, and then I brought it back to the shadow backdrop with stamps. Then I used a few nodes to extract the creature's shadow out of this pre-rendered image sequence, as you can see here. To create this fall off in the intensity of the blur that you can see when you look at the alpha channel, I used this masked eye blur gizmo, which I can highly recommend. I'll leave a link to this gizmo in the description of this video. After adding the creature's shadow to the plate, I merged the creature over the plate, added a transform node, a crop node, and a color correction to the B pipe. And finally, I renoised the comp with dust grain and mixed it back with the denoised comp with the resolve node to fine-tune the amount of noise that I wanted to keep in the comp. If you want to know more about dust grain, you can check out lesson 6 of this course. I transformed the whole image in this backdrop because I did not render any overscan with the creature, which you can see at the edges of the frame if I disable the Z defocus, soften, and motion blur node, look at the STMap node, and toggle it off and on. And since scaling the comp up just a tiny bit was the easiest fix, I went for this solution. Now I'm going to talk about the beauty rebuild setup of the creature, which looks quite similar to the beauty rebuild setup in every other creature shot of the short film. I rendered all of the creature's shots with V-Ray for Maya as deep EXRs because I wanted to have the ability to use the deep information as the depth pass, but I did not do that in this shot. I will get to that technique in the next lesson. Here's a quick look at all of the layers that I rendered for the creature. There are a few layers that I didn't even use, like the bump normals, the raw GI, the velocity, or the world XYZ pass. Before we get to the rather complicated version of my beauty rebuild setup, I wanted to show you a raw version of it, which is a bit easier to understand. You can rebuild your beauty rendering by plussing the layers together that make up the beauty render. Depending on the render engine that you're using, these layers might be a bit different and have different names. With the Arnold render engine, for example, you can render out a direct specular and indirect specular layer, which you don't have in V-Ray, but you still need to plus your beauty layers together to rebuild your beauty rendering. Now, I will not explain how and why you should use the unpremold and premold node, because there are many tutorials online in which this topic gets covered by great artists. But I want to give a shout out to Tony Lyons, because I used to add an unpremold node after every shuffle node of the beauty layers, and he told me to do that for all of the layers right at the start of the beauty rebuild, which I believe makes much more sense. Another awesome suggestion that Tony gave me was to add a remove node after shuffling out layers in my beauty rebuild setup to only keep the RGB channels of these layers. That way you can save a lot of rendering time, because only the RGB channels are being processed afterwards, and not all of the other layers that your 3D rendering comes with. So thank you, Tony, for your awesome suggestions. Alright, so let's get back to the beauty rebuild setup. In this case, it would have been enough to only plus the GI, lighting, subsurface scattering, refraction, and reflection layer together to rebuild this beauty rendering. But sometimes I like to add the diffuse layer into the mix to have a bit more control over the colors of my 3D rendering. By setting this merge node to divide and connecting the diffuse layer to this point of the beauty rebuild that way, I'm separating the lighting from most of the color information. And then I'm combining the color and the lighting information back again with the merge node that is set to multiply. This part with the diffuse layer is not a necessary step, but sometimes I like to use this technique in my comps. That way I can work on the diffuse layer before it goes back into the beauty rebuild. Multiplying the ambient occlusion layer over the beauty rebuild is something that I like to do to give my characters a bit more depth, but that is not part of the beauty rebuild and just a personal preference. Of course, you need to pre-multiply the RGB channels of your beauty rebuild with your original alpha, a copy, and a premold node at the end. And since you only have your RGB channels at this point, if you have created your beauty rebuild setup like I have, you can even use this copy node to get your depth back from your original 3D rendering by setting your copy node's layer copy drop-down menu to depth. I needed to do that in my setup because the ZD focus node obviously needs depth information to work properly. And that is the raw version of my beauty rebuild setup. If I compare it to my original 3D rendering, you can see that these outputs are identical. Now let's take a look at my more complicated version of the beauty rebuild setup for this shot. There are quite a few color corrections and other nodes that are manipulating the beauty layers and the ambient occlusion layer, and a few more nodes that are manipulating the output afterwards. On the right side, I created a lot of masks that helped me to confine many of the operations on the left side. Of course, I will not go through every single node of the setup with you now, because that would take up too much time. Instead, I'm going to show you the before and after states of the beauty layers, walk you through some of these sections, and talk about the area where I created most of the masks for this setup. Let's continue with the before and after states of the beauty layers. I left the global illumination layer as it was, made the lighting layer a bit brighter. In the subsurface scattering layer, I made the shadow area on his left deltoid a bit brighter. I also made the diffuse layer quite a bit brighter, changed the colors a bit, and made the creature's right hand significantly brighter because it was originally way too dark. I also made the refraction layer brighter and covered the core of the creature's eyes with a lot more green color. And I made the reflection layer and the ambient occlusion layer brighter too. So there is a lot of making stuff brighter going on, and tweaking the colors here and there along the way, of course. After multiplying the ambient occlusion layer with the B-pipe, I gave the creature an overall color correction, made the hair a bit brighter, gained down the arms and legs of the creature. Then I added some pixels to the hairs in this region that roughly have the same color to make them a bit brighter. And right before pre-multing the RGB channels with the original alpha and copying the depth into the B-pipe, I used the black smudge gizmo from Tony Lyons to adjust the black levels of the creature. I will leave a link to Tony's gizmo and his tutorial about it in the description of this video. Now, if we compare the original rendering of the creature with my manipulated version of it, you can see that it has changed quite a bit. Getting to this point demands a lot of trial and error. The cool thing about working on your own projects is that only you decide when your shot is ready. But I believe getting constructive feedback from friends and colleagues is very important and only makes your work better. That is why I wanted to take the time to thank Walter Gilsing, Sandra Blattner, and Tony Lyons. Thank you guys for giving me some awesome and valuable feedback about my short film. Okay, so after pre-multiplying the RGB with the alpha and copying the depth into the B-pipe, I Z-defocused the creature, added a soften node, and some motion blur to it. Since I didn't want to render all of the creature's shots in 4.6K because of the rendering time and a bigger electricity bill, I rendered them in half of the Ursa Mini Pro's resolution, which was totally fine in this case, because just reformatting the creature to the right format worked just like a charm, as you can see here. Right before merging the creature over the plate, I applied the lens distortion to it with this STMap and STMap node setup, which I have talked about in lesson 5 of this course. Finally, I wanted to talk about the utility layers I like to use and create masks with to manipulate my 3D renderings. Most of the times I like to use the world or object XYZ pass, the normal pass, and the UV pass. The world XYZ pass can give you the XYZ position information of each rendered pixel relative to the 3D scene. The object XYZ pass can give you the XYZ position information of each rendered pixel relative to the object. That means when your object moves in your 3D scene, the position data moves as well. Let me show you what I mean. In this setup, I used the Object XYZ pass for the creation of many masks. If we take a look at the alpha channel of this node, where it says Eyes Center, you can see that the masks in the eyes of the creature move along with the movement of the creature's head. I created these masks with the Object XYZ pass and the help of this PMask node. I'll leave a link to a tool from Nukepedia that also works with World and Object XYZ passes in the description of this video. Another utility layer that I like to use is the normal pass. Most of the times I use it in combination with another Nukepedia tool that is called W Supernormal, which lets you use the normal pass to create masks for color corrections, relighting, and much more. In this setup, I used it to help me with the color correction of the reflection layer. I'll also leave a link to the W Supernormal gizmo in the description of this video. The last utility layer I want to talk about is the UV pass, which you can use to retexture your 3D renders, create masks, and much more. I always use it in combination with the STMap node. Ideally, you shuffle out your unpremultiplied UV pass, keep the RGB, and get rid of the other layers with a remove node. Connect your UV pass to the STMap input of the STMap node, set its UV channels knob to RGB, and connect your texture or mask to the source input of the STMap node. Since this workflow is based on the UV information of your CG model, it can be very helpful to have the texture or UV snapshot of your CG model that you need in Nuke. That way you can see where your new RGB or alpha information should go. If I take a look at this node where it says reflection matte, you can see how the UV pass helped me to create a mask for the creature's mouth. I used this mask for the color correction of the reflection layer. If I toggle this multiply node off and on, you can see that I used the mask of the creature's mouth to reduce the reflection in that area. There is so much more stuff that I could talk about. But before I end this lesson, let's have another look at this shot. This is the transformed plate. This is the comp. And this is the graded comp. And that was it for this lesson. In the next lesson, I will talk about the creation of shot 230 and 240 of my short film nöck. Feel free to post any questions you have about my work in the comments, and I'll do my best to answer all of your questions. If you want to see more of these videos, don't forget to subscribe. Again, this is Lars Wemmje. Thank you for watching, and goodbye everybody.